How we doing, everybody? This is That Our Nerd coming at you with a quick video on how to make a random forest model within R, and also how to predict using that model. It's going to be a grand old time here on That Our Nerd's channel. So what we're going to be using is one package, really. It's a random forest package. Our part is just for explaining a little bit, but you can plug it all in and follow along if you like. So we're going to be predicting the iris dataset, and this iris dataset has 4 variables that we're using to try and predict what species of flower it is. So we have Setosa, versicolor, Veronica? No, that ain't it. I don't remember the last one, but we're going to use these 4 variables to try and predict our species. So let's take a look at one decision tree. So a typical decision tree, we take all our data and we look at the best possible split to try and discriminate between our different flowers that we're looking at. For this one, we're looking at all variables. Best split is petal length is less than 2.45. If it's less than that, it sends it this way, and it's a Setosa plant. And if it's greater, it sends it this way, and then it looks at the best possible split for the remaining data. And so the first difference in random forests, I mean, really, it's a forest, right? And a forest is bigger than a tree. Okay, there are many trees in a forest, and so that's the first part of random forest. The second part, the random. Some of the randomness comes in where we don't look at all possible variables at each split. We only look at the square root of the predictors that we have. So for this one, we have 4 predictors, and the square root of that is 2. So at each split, we're only going to be looking at 2 possible predictors. And so that's going to give us some variance, some differences between the trees that we look at in our forest. And then the last part of randomness is the bagging part, the bootstrapping. And so what that is we have 150 rows of data in our data set here. And we're not going to include all 150 in every single tree. What we're going to do is we're going to sample out of the 150. We're going to sample it 150 times, but with replacement. So there are going to be some extras in there that are included, which means some are going to get left out. And on average, it's about a third that get left out. And then we actually use those for a kind of training, so we can get some accuracies on it. So without further ado, let's make our model. Random forest is awesome. I mean, it's just so easy. Okay, so we'll do random forest. We're going to say, how does species depend on the rest of the variables in there? Yeah, you can specify and put plus signs in between if you want, but this is pretty easy, right? For this one, we'll put importance is equal to true. You won't really want to do this if you have a large data set with like millions and millions of rows, because this actually makes a n by n matrix that shows the closeness, and it's very large and time intensive if you have a large data set. But for this one with 150, we'll put it in and show what it does. We'll say our data is equal to iris. There it is. Our random forest is done. Let's take a look at it. So for this one, we have 500 trees, so that's the default. And again, the default is we're going to look at the square root of n, so square root of 4, which is 2 variables at each possible split. And then we get the out-of-bag estimate of error. And so, like I said, about 33% of our data doesn't get used. And so that 33%, we end up throwing down our 500 trees and predicting with it. And that'll give us our at least somewhere to start with. So Setosa predicted 100% correctly. Versicolor was 47 and 3, so 6% error, which means 94% accurate. 8% error on Virginica, and so in total we're at about 95% accuracy, which is pretty good. There are only 2 real knobs you can switch to try and tune with random forest, and that's really why people like it a lot. With like gradient boosting, you can get more accurate by a few percent, but it's going to take a long time and a lot of effort to try and train that model. So let's just take a look at randomForest. So the two real things that you can switch are the number of trees that you want to use. 500 is pretty good for small ones, but if you have larger data sets, you're going to want to use more trees. But that also slows down your process, so it's kind of a balancing act of, you know, how accurate versus how long do you want it to run. And then too many trees, you're probably going to overfit. And then the last one is this mtry. So this is the number of variables that you look at each split. So you can specify if you want to look at 3 instead of 2 or 1 instead of 2. And like I said, it's the square root of p. If you're doing classification, if you're doing regression, it's your number of predictors divided by 3. Okay, so let's take a look at the varImpPlot. So this is pretty neat here. It actually shows what the most important predictors are in your model. So the most important one is petal length and petal width. And those are actually pretty significantly higher than sepal length and sepal width. This mean decrease in accuracy isn't like super helpful. Like it doesn't really mean much, but it does give you a good idea of what are the most important predictors. Something that does happen though is if it goes below 0, it means it's actually hurting your model. Like adding that variable is actually worse than random. So you probably want to take those out of your model. Those aren't great. All right, let's predict. So we're going to make y. We'll do data.frame. In that data frame, we're going to make a matrix. And I already made these before, so you can just kind of type them in and then I'll talk about them. We got 6.4, 5, 2.6, 3.4, 5.2, 1.5, 1.6, and 0.4. And we have 2 rows. Let's take a look at this down here. So it kind of makes sense to me that like you're trying to put rows in, but that's not how you type it into this matrix. It actually is a vectorized language, R is, and so it goes up, down, and then there, and then there, and then there, right? So 6.4 and 5, 2.6 and 3.4, and then all the way over. To be able to predict these, we need column names. So we want these to be the same column names that we had above. So let's say call names of y. And into those, we're going to put sepal.length, sepal.width, petal.length, and petal.width. So again, these need to be the same exact names that you have on your data that you put into your randomForest model. So let's take one more look at y. So now they're properly named, and it's going to predict, given these 4 variables, what flower does it think it is. And to do that, we'll do a predict. You put your model, and then your data that you're predicting. And so it predicts the first one is a virginica, and the second one is a setosa. Pretty neat, right? Something you might be interested in is like the probability of it being these. And so really what the probability is we threw it down all 500 trees, right? We threw 6.4, 2.6, right? We threw that down all 500 trees. And what percent of the time did it end up as the different trees? So for that, we'll do type is equal to prob. And so for this first one, it says 47% of the time it's versicolor and 52.8% of the time it's virginica. And again, this number might be a little bit different for you just because we are using randomness in our randomForest. And so our forests are going to be a little bit different, but should be pretty close to that. And so because it is the highest percent chance to be a virginica, it ends up predicting that it is a virginica. For setosa, it said we threw down all 500 trees and every time it was a setosa, so it's a 100% chance that it's a setosa. All right, hopefully you found that helpful. If you did, make sure to press like so other people can find it. If you want the best R content ever, subscribe to That R Nerd. Thank you. Have a great day.